Now, a likely meaning for the graph in the preceding, for the graph trapezoid in the preceding, is that graph altitude represents how fast something might be moving. It's moving at 10 meters per second here, and 5 seconds later it's moving at 20 meters per second. The trapezoid width, and I wrote width instead of width. Let me fix that. Okay, now, not a great looking word, but width. Trapezoid width represents for how long the interval lasts. It's the duration of the time interval. So we have something moving at 10 meters per second, 5 seconds later moving at 20 meters per second. Okay, so what would the slope and what would the area of this trapezoid represent? So I can make the following statement. If the approximating segment, line segment between here and here, accurately represents how the quantity, how fast, evolves in time, that is, if the how fast really increases at a constant rate from here to here, indicated by the straight line, then average altitude times width is going to represent how fast on the average multiplied by how long the motion lasts. Now, that means how fast on the average would be, in this case, 15 meters per second. And this would be 5 seconds. So when we multiply these, this tells us how many meters every second, which is 15, multiplied by how many seconds, which is 5, which tells us that that's going to be 75 meters. So that this result will end up as 75 meters. And that's, of course, consistent with how the calculation turns out. Now, what about the slope? Okay, I took up more space here than I intended, so I don't have an abundance of space up here, but hopefully this is legible. The slope is what? Well, it's the rise, which is the change in how fast the object was moving. Okay, so the object in 5 seconds, how fast it was moving changed by 10 meters per second. And we divide that by how many seconds, and what do we get? We get how fast changes per second. Now you might want to digest that statement. I'm going to modify it slightly to make a little better sense of it, but that's really what it is. You might think about how that would manifest itself in various situations, a car rolling down a hill or whatever. And then that equals, I say, how quickly, how fast changes. Okay? Now those phrases are again worth trying to understand and trying to imagine. Okay, I've made a change in my wording. Instead of how fast, I talk about speed. So slope is the change in the speed. The speed goes from 10 meters per second, 20 meters per second. The change in speed is the difference, which is 10 meters per second. And that's how much the speed changes per second, which tells you in a very tangible sense how quickly the speed is changing. So again, something you might want to think about. You might want to think about the fact that if this only lasts for 2 seconds, then the speed is changing more quickly. If this lasts for 20 seconds, then the speed is changing more slowly. You might even think, well, we'll leave it at that for the moment. Okay, and of course I could take how fast down here and replace that with the word speed. And I'm going to go ahead and do that. You might think about how that's going to turn out and what it's going to mean to you. And I've changed my wording now in the calculation of the, or the interpretation of the area. Graph altitudes represent speeds. So if the approximating segment accurately expresses how speed evolves in time, then the average area, which is average altitude times width, represents what? Average altitude is going to now represent average speed multiplied by how long the motion lasts, which is basically then how many meters every second, because that's what the average, well, that's one way of measuring the average speed. It's the way that we have chosen in this particular graph, or at least it's the way that's consistent with this particular interpretation. So the speed is basically how many meters on the average every second. multiplied by how many seconds, which is how many meters, which we call distance. So there's a very concrete interpretation of this trapezoid and its slope and its area, how quickly the speed is changing and how far the object travels.